has been 2 years of us struggling to find a time to create something meaningful to provide to our membership, and something that can be long lasting and usable. And so I think it has taken us a little while to come together and do that. But the sessions that we've got set up for you for today and tomorrow are very interesting. I think they run the gamut of invasive plants and how they relate to the natural ecology of our area. And hopefully you guys will really enjoy what we've put together for you. So without further ado, I think we're going to go ahead and get into it. And our first presenter today is Dr. Dee Eggers. She is a professor at UNC Asheville, where she teaches natural resource management, environmental policy, intro to environmental science, and senior level humanities. She has a lot of research interests, one of which is invasive exotic plants. And so rather than read out what she's going to talk about, I'll let her intrigue all of you. So without further ado, here's Dee Eggers speak with you about the invasive exotic seed bank. Dee, I think you are up. You're good to go.
Okay. Can you see me? Oh, okay. I can see you. I didn't know if I was on screen. So hi everybody. Good morning, and thanks Owen for that introduction to today and tomorrow. It reminded me, when we think about the persistence of exotic invasive plants, that James Herod Booner said, exotic invasives are nature's way of screaming her medicines to us, because so many invasives are so successful because they have extraordinary capabilities in terms of antiviral, antifungal, nitrogen management, etc. So we have a lot to learn from them. At the same time, we of course need to control them. I'm going to attempt to share my PowerPoint now. So alrighty. Okay, now I can see myself, and it looks like. Can you guys see my PowerPoint?
Yes.
Yes.
Okay.
You need to be in. There you go.
Okie doke. Alrighty. So my talk today is on invasive seed bank management. As Owen said, I am a professor at UNC. I actually teach several other classes that weren't mentioned, but I will tell you that exotic invasive plant management is probably my most therapeutic class that I teach for both myself and the students involved. I've been here at UNCA since 1999, and I have been teaching exotic invasive plant management since 2013. So the seed bank, now we all know something about this, but I'm not sure how much. So when we think about seed banks, factors that we need to be concerned about are, number one, the input of seeds per year. How many seeds is the plant making per year? And number two, viability, which of course can range from sometimes as little as 1 to, hundreds or thousands of years in some cases, but usually a couple dozen maybe. So most noxious weeds produce thousands of seeds per plant, with some producing over 1 million per plant per year. Typically, when we look at a seed bank, so the seeds that are still viable from, however many years past, we see millions to, in some case, billions of seeds per acre. And here is this is actually out of Nevada, but it's a nice graphical representation of some species that we will find familiar, but like seed production, hundreds to thousands to, hundreds of thousands in some cases. and then longevity or viability. And of course, over time, mayweed chamomile may have a 25-year longevity, but over time some are becoming less and less viable, some are sprouting, etc. So the prevalence in the seed bank of those seeds is decreasing. But staying on top of the seed bank is really going to be a key factor in success for invasives management. In one example, Lamb's Quarters Chenopodium album was controlled on a site for 6 years. So during those 6 years, the plant could not be adding to the seed bank. That was denied. And that resulted in a 94 to 99% reduction in seeds in the seed bank. However, then after 1 year with no control, there was already a 90% increase in the seed bank. So, these relationships are also, they're nonlinear. So for us, they're not very intuitive necessarily. But what was that? I heard a saying once, 1 year of 1 year of seeds and 7 years of weeds in terms of what happens if you don't weed your garden for 1 year. And that has stuck with me since childhood. So effective seed bank management is going to be necessary to control invasives. And what we need to do is reduce the input of seeds. So we need to reduce seeds being added to the seed bank. And we can do that by killing plants before they set seeds, harvesting seeds before they accrue to the seed bank, and in other various ways. We need to, if we can, increase germination of the seed bank through some means to kind of blow it out, if you will. And if there's a way to do it, it would be great to increase seed mortality. So reducing the input of seeds is relatively easy, especially if it's a beautiful day and you've got a class full of students who'd like to go outside. So, and outside happens to be a place where you need to control something. So if you can see, actually in this, there's obviously a student in the foreground, but there are 3 other students back here in this image. And this is just down slope from my building. And this is a slope that is covered with miscanthus. And so I said, there was about 20 minutes left in class. We'd been working hard, and I said, do you want to go outside? We need to cut these seed heads off. And I explained to them, and they said, yes. So we went outside and did quite a bit of work, and folks were pretty proud of what they were doing. So we were cutting these off before they got so fluffy they were blowing away, putting them in plastic bags. And this is my environmental policy class with what they did, or actually, sorry, no, this is my ethics class with what they did. And this actually tied in beautifully to the ethics material, and we related it back to Eastern and Western ethics. But we didn't get everything. As you can see behind them, there are still some seed heads. So my policy students went back the next day, and we got everything, and we turned the site into one that was just nothing but miscanthus to, as you can see up here, you can't see the whole site, but we got everything. And that's a lot of work, and it's not always possible, but it is inspiring and educational, and it is going to help with this site. I think it's important to consider inspiration and education. A few weeks ago, one of my former students from years ago, who's an AP environmental science teacher at Asheville High School, she and I organized a couple of days to mount a bit of an attack against this kudzu that's taking over some trees nearby. And we got several people there and involved Greenworks, and it was a good community event. And we were just cutting vines high and low, and we're going to go in with goats and then go in with chemicals, with follow up, and do some more of this. But it was really inspiring to the people who were there. And part of the reason a lot of people showed up was because we tied it to climate change. So what we found was, when we talk about, because awareness of climate change is increasing so much now as compared to years past, when we tied it to, like, this is an aside, don't worry, I'll talk about seeds in a second. When people can see vines, they're exploding, they kill trees, that's going to release tons and tons of stored carbon. We can't have that going on right now. So people seem to really pay attention to that framing and get a bit more motivated. But back to seeds. Okay. So effective seed bank management is necessary for effective long-term management of invasives. Now, we know a lot of things about reducing the input of seeds, but what about increasing germination and increasing seed mortality? So this brings us to the year was 2009, and I learned about EM1 at the Organic Growers School. So there was a day-long soil special session preceding the Organic Grower School. And there was a guy there who gave a relatively long presentation. This was all down at Living Web Farms, who does, I think, the most cutting edge, actually, beyond sustainability stuff, possibly in the US and some of the most advanced in the world. I'd encourage you to check out their website. So down at Living Web Farms, this guy's talking about EM1, which I had never heard of. EM1 is a consortium. It's the only consortium we've actually ever found. So it's a team of soil microorganisms that was discovered by Dr. Tsuero Kiga, a Japanese professor back in the 70s. He talked a lot about it in public and published things and talked to his graduate students because he wanted it to be technology available to the world and to not be able to be patented. Anyways, the guy talking at the soil conference made a lot of claims, and I wrote them all down. And he claimed effective microorganisms can be used to increase crop yield, protect crops from disease, reduce putrescence and odors, purify waterways, cure MRSA, as in staph resistant, or excuse me, antibiotic resistant staph, used to prepare operating rooms in other countries by spraying them down and killing the pathogens present because it eats the pathogens present. And then any organisms that are present are part of EM1, which is part of our microbiome. They eat fat and grease, eat other fungi and bacteria, restore fisheries, shellfish beds, reduce manure odor, and reduce body odor, treat athlete's foot, toenail fungus, yeast infections, irritable bowel, Crohn's, diarrhea, constipation, increase mental clarity if people use this orally, increase energy and reduce sugar and carbohydrate craving, and protect against intestinal pathogens and foodborne illness. So I'm listening to this and I'm thinking, okay, these claims are extraordinary, and my detector's kind of beeping, and I thought I need to look this up and confirm some of this, because if it's true, it's pretty incredible. But it really stuck with me. And a couple years later, a friend of my sister's mentioned something about Crohn's, and I said, I remember hearing something about that. Let me look it up. So I looked up some stuff about EM1, and what I found was pretty extraordinary. And so I started, this is stuff that you purchase from, I purchased it from Terraganics, and they have the license in the US. It's also available at Fifth Season and some other places. Anyways, this gets activated, and that 1 gallon turns into 20 gallons of soil inoculant. And so I started kind of putting it on everything and had a pretty extraordinary garden that year. And I was noticing some things that were going on with seeds and everything else. I'll come back to this. I kind of put it on everything, accidentally killed some stuff with it, had some stuff do amazingly well, seemed to cure some things with it. And then I had this aha moment while I was standing in my driveway, and I thought, wait a second. When we put this on seeds at recommended rates or slightly above, and those are, here is a 1 in 1,000 dilution. Recommended rates would be like a 1 in 10,000 or 1 in 100,000 dilution. What I noticed on, these are just little white Dutch clover seeds. What I noticed was I had more rapid germination, and the plants were vigorous and very healthy. And I thought, well, what if you add more? So I tried higher concentrations, but at higher concentrations, I noticed the seeds might sprout, but you can see like the root radicals might be smaller. And zooming in even a little closer, you can see that the tip of this root radical, this has germinated, but if there's any brown down here, this is going to die. And so I'm standing there next to my truck, and I was literally looking at rainbow chard and thinking, wait a minute, can we use this to actually blow out weed seed banks? and thus began several years of experimentation. So can we manipulate the seed bank with EM1? Can we increase germination, and then kill the plant before it sets seeds? And can we terminate seeds? So I did many experiments. I experimented with this just, you know, in the living room window, in trays, on paper towels during the winter. I compared the effects in sand versus soil, or, you know, miracle grow, something with higher organic content. I experimented with what if we send them in with, you know, some extra food, like sending them to work with lunch. So we activate this, get it down to a pH of, you know, 3.2 to 3.5, do the dilutions with non-chlorinated water, and then add a little bit of extra sugar or molasses. Do we see an increased effect from that? I did experiments inside, outside, and in a growth chamber, and multiple experiments inside and outside in the growth chamber. And I want to talk about a couple of those. So the first one is what I'm calling Lower Miller, because it was below Miller Hall, which is one of the buildings on campus. So in this experiment, we looked at 3 different species, and we used 100 seeds of each species in each plot. So we had these half-meter plots that we made with distance between them. And we looked at buckwheat, white Dutch clover, and mustard. We tried 13 different treatments. I'll explain a little bit more about this, but different concentrations of EM1. And we did some of those with sugar and molasses, and those each had 3 replicates. And then we replicated them without sugar and molasses and had 3 of each as well. We ended up with 39 plots for this, and we hand counted out 11,700 seeds and carefully put 100 seeds of each of the 3 species in each plot. And then we covered them a little bit with the soil that was there, and we inoculated each plot with the same volume of inoculant that contained a mixture of EM and or sugar, molasses, or neither. So the amount of EM1 per plot varied from 0 for the water control to 950 milliliter. The effects, we looked at the effects of using sugar or molasses or neither. We also did a vinegar control to look at whether what we were seeing was actually just because of the pH. And the answer is definitely no, but you can certainly do a lot with vinegar. 3 species, as I said. Now, the duration of the whole thing was 269 days, which is an odd number, but we were getting pushback from the administration, who wanted to convert this area back into a lawn and not have on the campus entrance going up to the arena a large area on the left with a bunch of strange looking plots and flags all over the place. And because of the weather, it just ended up that the best day to do the final count was day 269. You might also be thinking, there's probably nothing to count on day 269, given the species and how long they live and dormancy and things. But we did count everything on day 269 because we also included the weeds, whatever weeds were there that were part of the existing seed bank in the spot. Here's the location. So this is our facilities building. This is Kimmel Arena on campus. And this green area was where we had these plots. Down here, this is a wet pond, technically a wet pond that gets runoff from some of the above parking lots. This will become relevant later. The water that we used, by the way, was collected from the rooftop of Sam Miller. Sam Miller is an extremely green building, and the toilets and things are flushed with rainwater, etc. So we were able to get rainwater to water the experiments. So we weren't introducing any chlorine into them over the course of the summer. So let's look at some numbers. All right, clover. And by the way, I am keeping track of time here. Okay, so clover germination, day 70. Really, we kind of saw all there was to see by about day 21, but just so you know, in terms of any stragglers or effects of delayed germination, which really is not what's going on here, here's what we knew by day 70. So there are two lines here. One line is the blue line, which were the treatments where we said, hey, what if we send them with lunch? And so we gave them some extra sugar or molasses, so we varied those concentrations based on activation, etc. I'm not going to talk about that. Didn't seem to have much of a difference or much of an effect, but a little bit. Anyways, the orange line was when there was no sugar or molasses. The x-axis shows you how many milliliters of EM1 were in the initial total 2-liter inoculant in each of the plots. This line's not connected right here because Excel didn't want to connect it because I didn't have a 50, because that cell was blank and I didn't want to extrapolate and mislead you. But anyways, there was a 0 here. Also, this goes to 950 because here we did a little more at the lower end, and here we did a bit more at the upper end because we were doing a pretty complicated design with a lot of parameters intentionally. Anyways, you can obviously see that there's a pattern here, and the pattern is basically the more inoculant, the fewer plants germinated over this period. We went to day 269, and in fact, I walked up in that plot afterwards, and no seeds germinated after this, no seeds that we had initially introduced of the 3 test species. So this was the end. Notice that there's a little blip here at 50. So we kind of see this like maybe there's increased germination. These points are the average of the 3, by the way, the 3 different replicates. There's a little increase in germination and then decrease and decrease and decrease. What we're going to see more of this, but just so you know what's going on, what I have noticed is if you give a little bit more than what is recommended, what you see is increased germination for any given species. And then if we go beyond that, what I see is a decrease in germination and an increase in seed termination or death. So this is just if you're interested, if the statistical testing resulted in anything. So day 269, we see about the same thing as we saw already on day 11. Any numbers that do not, any rows, I should say, that do not share letter with another row's letter are statistically significantly different. And these were definitely statistically significantly different, at least falling into kind of 3 categories, using Fisher also with Tukey. Mustard germination, day 70, we saw a similar pattern. Again, well, mustard is just like, yay, I'm germinating. Interesting thing going on with the sugar there, but beyond the scope of this talk, little increased germination and then decreased. And then here we see with the no sugar, just overall decrease, decrease, decrease. So we're seeing more mortality. Mustard seeds are very small. They're very small. They're difficult to count. If you ever have to count them out, do it on a t-shirt. Otherwise, they'll go everywhere. But they're small, and so they also have a small coating. And so we might see some difference in them compared to larger seeds because of that, which will make sense in a minute. So with mustard, Fisher pairwise comparisons, we've got statistical significance here as well in terms of the lower groups. Buckwheat germination, day 70. You first of all might say, why is there only 1 line? Well, there's only 1 line because I combined all of the data because the sugar and molasses addition didn't result in any significant difference in terms of the standard deviation. And so the means could all be combined and it was fine. So very robust, kind of interesting. We see this uptick here at the lower level, increased germination and then a decrease in germination, but really not as much of a decrease as I might expect. And based on the other experiments I'd done, I thought, I should be seeing more. Why am I not seeing more here in terms of the decrease in germination? This is weird. Also, it's not statistically significantly different. And there were some other factors going on that had to do with some of the plots got a little more shade than others. some got far more sun all day long and were just hammered by sun. And what it seems happened in those really sunny spots was they may have dried out, and early on we saw the effect we predicted, and then it went away, which we saw happen in other experiments too. Just by the way, with weeds on site, this is no inoculation, this is just what happened to be there. And so we just happened to count them. And so again, the difference is blue is sugar molasses addition, and orange is nothing was added. And with the sugar molasses, interestingly, over time, this is at the end, day 269, and these were all cumulative counts. So maybe we are increasing germination of the seed bank to a point and then seeing a decrease. There was this down here though, there was a lot of noise in this, and so I'm not so sure about that. And then interestingly, we might see an increase here as well. And then it seemed to kind of level off. But the take-home message is increasing germination in the seed bank. Now, I was kind of frustrated with the buckwheat because based on what I'd seen, I didn't think that what happened with the buckwheat outside would be what should have happened. So we, the U.S. Forest Service let us use their growth chamber to do an experiment that was highly controlled. It didn't have slugs and rabbits and weather. And oh, and by the way, we had some weird weeds in some of the plots. And I said to head of grounds, like, why is this happening? And I said, is there different soil in some? And she said, oh, we dredged that pond occasionally, and we put all the dredges in the middle of your site before you did the experiment a couple years ago. It didn't tell us. And I was like, oh, okay. Well, that could introduce some interesting factors. So off to the growth chamber, what's the miracle grow? So we did 4 different concentrations, and we wanted to see, is the issue not having enough time exposed to the EM1? So we actually soaked the seeds for varying amounts of time, and we did 3 replicates of each, 100 seeds per container, 72 containers, so 7,200 seeds in this experiment. And you can see in terms of the statistical significance here, we got soak time and concentration were both highly significant. Now this is a simplification. Let me explain this graph. You've got 4 lines. The yellow line are seeds that were soaked in 100% EM1. On the x-axis, we have the time, 0 hours. In other words, put them in the container, drained them, done. Rinsed them off. 3 hours soaking in EM, 6, 9, 12, and then 16. And so that was 100%. The gray line is a 50% concentration. The orange line is 10%, and the blue line is just a water control. So you can see not a lot of difference between 0 and 10 in terms of germination. So we weren't seeing termination even after 16 hours in 10%. We were, though, starting to see termination when we started getting up to 50% and 100%. So again, this, a little bit of time, even at a high percent, we saw an increase in germination, interestingly, but then more time, higher percent decrease, which was expected. By the way, ways to get this wrong, if feel free to contact me about this, but ways to get this wrong, if you let the soil dry out entirely down to a depth of 1 centimeter, your experiment's probably over. The effect is probably gone. So you've got to keep it moist-ish for at least, I'd say 2 to 3 weeks, which can be pesky. Got spring and fall are going to be handy. Soil type. If the soil's too sandy, the EM1 is going to die, basically. You'll see an effect early on that you expect, and then it will attenuate because they don't have enough organic matter. Under-apply it, store the EM1 improperly and kill it. Apply it during the day in direct sunlight, and the UV will kill it. So this needs to be, I always apply like at dusk. And if you try to activate or water using chlorinated water, that will be a problem. So with that, I will say thank you. And are there any questions? And okay, tell me, am I supposed to look at the chat now? Because if I I need to stop sharing.
Dee, there are no specific questions in the chat right now, and so what I would say is, I would offer up anybody, you're welcome to enter a question into the chat now. I just noticed now, I am trying to send a question in the chat, and I don't know if I have the ability to send it. So perhaps the IT folks could have a look at that. Maybe other people are experiencing that. But I have a question for you, Dee. Have you used EM1 on microstegium? Do you know how microstegium responds to it?
Okay, well, I have, and I have not done any tests with microstegium. The casual interaction I've had with microstegium, shall we say, excuse me, bench level investigatory experiment of just dumping it on microstegium and kind of seeing what happened. The microstegium was like, oh, that hurt, but I am not really hurt very badly. So I don't know. And grasses are interesting things. So I haven't really done major investigations. We did actually install a huge experiment outside with many plots and hundreds of seeds, including grasses. And then we had a 3-inch surprise summer rainstorm 1 hour after we installed the experiment. So we didn't get anything from the experiment.
Gotcha.
So, yeah, I mean, maybe we will look into it when I teach the class this spring.
Gotcha. Well, Dee, thank you so much. That was fascinating. I've long wondered, it's almost like that's the fourth dimension of invasive species control, trying to get ahead or understand the seed bank. And I think that, it's really interesting to see what kind of implications your casual research could have when flushed out, and looking at areas that are, completely invaded, and looking at reclamation or restoration activities. I think that could have a lot of.
Yeah. Sorry, I should have added this. So all those claims that guy made at Living Web Farms, those are true. And I think this is actually a really kind of game-changing approach, because it's using all the species in EM1 are native, they're naturally occurring in the environment, in the soil microbiome, and in our gut microbiome. And so it's not adding any chemical that's going to cause harm. More of it's not really going to cause harm if we add more. And so it also helps plants be healthier and fight disease and things. So it's adding something beneficial to a system to help it improve its overall health, which is a completely different approach to thinking about the system dynamics of anything else I know of.
Awesome. Fascinating. Thanks so much, Dee. We really appreciate you presenting. And if anyone has any questions for Dee, like I said, we will make contact information, abstract and bio information available, and send it in the chat to y'all later. So thanks again.